Hello friends, welcome back. In the previous tutorial, we have seen or learned how do we check whether two rectangles are getting collided, what are the steps that we are going to carry, and we understood little bit about axis aligned bounding box collision. Now what we are going to do in this tutorial, we are going to understand little bit more on axis aligned bounding box collision, what we do actually. Before I proceed and explain AABB or axis aligned bounding box, let me explain about pivot point. What is pivot point? Now here you can see that I have an image on the right hand side, a fish, and it has its own rectangle bounding box. Let me select this. If somebody told me, consider this image's left bottom as a pivot point and place this image at 0, 0 or at the origin, then what I do, I click over the pivot point and I drag the image and I place it over here. Now this is how we are going to place the image. Now this image's x and y is 0, 0 guys. Let us put it back. If somebody told me that consider the pivot point as the center of this image, then if this is the center of this image, if this one is considered as a pivot point, if somebody told me that place it at origin, then I take it and I place it over here. Now the image x and y will be 0, 0. Understanding? Based on the pivot point, its x and y will be calculated. Based on the pivot point, the object will be placed on the scene. Understanding guys? On the graph. What is the meaning of pivot point? How pivot point helps us to position the objects, or how pivot point affects the placement of the game objects. I hope you guys have understood. Now let's proceed. Now whenever you bring some image in the scene or in the game, every image is going to have x and y property. Of course, every game object is going to have x and y property, that we already know. If I want to get, first thing we need to get the rectangle box or the bounding box of that game object. If I want to check whether two objects are collided with each other or colliding with each other, then I need to get the bounding box around them. How do we get the bounding box around that game object or around any game object? Sometimes the engine itself gives you a facility of getting the bounding box. In Unity, if you want to get the bounding box around any game object, then you can use the renderer class, or we are not going to know what is renderer class and all at present. I'm just giving you a brief information that there is a class called renderer which helps you to get the bounding box of the game object. Now here, as we know that we don't have any bounding box known at present, we know only x and y of the image. What is the x position and the y position of the image, and we also know what is the width and height of the image. So based on that, I can create a rectangle. Rectangle I can create very easily, as we know that the rectangle is going to have the property x, y, width and height that help me to put the image or the game objects x, y and width, height. So first thing, let's create these rectangles. If the engine or the system itself provides, then there we need not to create the rectangle class and all, we just can get. But here we need to create ourselves a rectangle class so that we can put the game objects rectangle, values. Now here this rect1 indicates this first fish image rectangle. Rect2 indicates the second fish rectangle. So we need to create some imaginary rectangle boxes around these two fishes. So let's create them. We have here already created the rectangle class which has x, y, width and height property. Using that we can create. So what I do means I just comment this complete code so that we can write the code from scratch. This part, I just collapse this. Let's write the code then. First thing I create, for first fish, I create a imaginary rectangle box around it. Rect1 is equal to new rectangle, and you can see here in this graph I have considered this left bottom of the image as the pivot point. So its x is 50, y is 50, width is 100, height is 100. That is the reason I have written here rect 1, 50, 50, 100, 100. Let's create that. 50f, 50f, 100f, 100f, bracket close. This is a rectangle around the fish 1, or I can say here instead of rect 1 I can say fish 1 rect. You can write any variable name here, a reference name. This gives us the first rectangle. Let's create for second fish. That is going to be rect 2 is equal to new rectangle, and let's check it out. What is its x, y and width and height? Its x, y is 200 in x and y is 100. You can see that. Let's write that. 200f, 100f, width is 100f, height is 100f. Now we have imaginary rectangles around two fishes on the graph. We have this rectangle box. Next step is to calculate axis aligned bounding box. Now here axis aligned bounding box is just another few properties of the rectangle. Like this rectangle, let's take this rectangle. What we do means we project its side on the x-axis, we project its side on the y-axis. You can see these blue lines that you see, they indicate we have projected. You can think like we have got the shadow of this side on the x-axis, shadow of this side on the y-axis. Now here this point indicates the left property of this rectangle box, left, and this point indicates the right property of this rectangle box. Similarly, this point indicates the bottom property of this rectangle box, and this point indicates the top property of this rectangle box. So left, right, bottom, top. We are going to get these four properties to get the axis aligned lines or box, you can say. Now what we do, let's first thing we create those properties here. First, as we know that the properties we are creating, float, first one is the left property. I can use capital letter for the first character, left. And what is left? It is actually going to be the getter. We cannot set the axis aligned bounding box properties. So left, we are going to return return, return this dot x. You can see here, this is the left of the rectangle 1. So left indicates x. X is equal to left, left is equal to 50f. I am just telling for the rect 1. You can check that one. If you want, you can get that here. Now we have the facility to getting, I can get for both, no problem. Let's check it out here. Debug.log rect 1 left left is equal to double quotation plus rect 1 dot left property. You can see I am going to get here 50. Why I get 50? Very simple. The reason is we know that the property is returning this dot x. So what is the current rect 1 x is 50. I save it, come back to Unity just to show you. I run the code. You can see that rect 1 left is 50. Remember this. Next, we can get the rect 1's right. If I have to get the rect 1 right, we understand this. Please try to understand clearly what I am explaining here. Rect 1's right is going to return us, you can see in this graph, if I have to get this point, rect 1's right, this indicates the right point. If I have to get this, I have to take the x and add the width so that I get this point. Simple. what I need to do here, I have this dot x plus this dot width. It gives me the right RIGHT, right. Let's save this one and get that. Debug.log, I'm going to get rect1 RIGHT, right, is equal to double quotation plus rect1 dot right. Now right value is going to be 50, that is x, width is 100, so 50 plus 100, 150. We are going to get 150, and also in the graph it represents 150. You can see that. Let's run and check. If I run the code, you can see that rect1's right is 150. So we are step by step getting the information. Next I create another property that indicates the bottom, BOTTOM, bottom of the rectangle or bottom of the image, and that actually indicates the y value. Simple. Let's calculate and display that. Debug.log display rect1's right, we have rect1's bottom, and the bottom is going to be obtained by the bottom property. I just save it and come back to Unity and run and show you. You can see that we got rect1 bottom is 50. Next I need to get the top. How do I get the top of the rectangle box? To get the top, I say here top, and the top property we can find out very easily. You can see this indicates the bottom that we have already got 50. If I add the height of the image or the rectangle box, I get this top point. If I have to get that, I have this dot y plus this dot height, that gives me the top. Full stop. I just save it. Here I am going to calculate the rect1's top property, rect1 dot top, and here I am going to write top, and top is very simple. Y is 50, height is 100, so 50 plus 100 we are going to get 150. Let me save this, come back to Unity and run and show you. If I run the code, you are going to get top as 150. Good. Now we can very easily find out what is the left, right, bottom, top for the rectangle 2. I can just copy this code and paste it down and change wherever I have 1, I just change that to 2. So here also I change it to 2, 2, 2 and 2. Let me save this and run and check. If I run the code, you can see that rect2's left is 200. In the image also we can check that. Let me minimize this. If you see in the graph, you can see x is 200 or the left is 200, rect2's right is 300. 200 plus 100 is 300, that is what we got. Rect2's bottom, rect2 bottom is y value, that is 100, you can see that. Rect2 top is height plus y, so we are going to get here 200. Once we got all these values, now we can check whether these lines are overlapping on one another. You can see this rect1's line or the vertical line is overlapping with the rect2's vertical line, and here you can see that rect1's horizontal line and rect2's horizontal line are not overlapping. These two rectangles are considered overlapped if and only if both the rectangles, the horizontal and the vertical lines are overlapping. If all the conditions are, if both these two vertical lines, these two horizontal lines are overlapping, then only we say that these two rectangles are overlapped. Otherwise they are not overlapped. Understanding? That is the technique of axis aligned bounding box collision check, friends. So what we do means, first we want to check, we can check whether these two lines are overlapped or not. Whether these two lines are overlapped or not, we can very easily check by writing the if conditions. How do we write the code means, what we do, we take rect1's left. If rect1's left is, we are going to check whether it is less than rect2's right. We check something like this, rect1's left is less than rect2's right. We are going to write the condition like this. Let's write the code so that we can check the collision things. If rect1 dot left is less than rect2 dot right, and we are going to check rect1 dot right is greater than rect2 dot left. This will tell us, these two lines, these two codes tell us whether these horizontal lines are overlapping on each other. At present, if you check the condition, rect1 left is what? Rect1 left is 50 and rect2 right is what? Rect2 right is 300. That condition is true. This condition is true. Let's check it out for this condition, whether this condition is true or not. Rect1 right is greater than rect2 left. Here rect1 right is 100 and rect2 left is 200. Whether 100 is greater than 200, the condition is false. If any one of these condition is false, we know that these two lines are not overlapped. I can check that one. I can easily say here debug.log. I can say here horizontally overlapped, overlapped. I can say that rect1 and rect2 are horizontally overlapped if and only if these both conditions are true. Both conditions are true, and we know that as they are not overlapped, if I save and run, we are not going to get horizontally overlapped. Now we know these things. I just comment these lines because I do not want to display those things on the scene. I just save these things and check out whether they are horizontally overlapped. If I save and run, I am going to get the output as they are. I'm not going to get any output because they are not horizontally overlapped. Just save and run the code. You can see that I didn't get any output. I'm not getting any output. What I do now, we can check for vertically also. To check vertically, we are going to check something like this. If rect1's bottom is less than rect2's top and rect1 top is greater than rect2 bottom. You can see that how we are checking, guys. I'm going to copy this line, I paste it down, and I'm going to say here vertically, vertically, vertically. Save this. And if you see this graph, vertically or vertical lines are actually overlapped. You can see that. And we can understand the condition. Here the condition is rect1 bottom is less than rect2 top. Rect1 bottom is 50 and rect2 top is 200. Whether that is true? Yes, the condition is true. Let's check for this condition. Whether rect1 top is what? Rect1 top is this 150 is greater than rect2 bottom. Rect2 bottom is what? 100. 150 is greater than 100, so condition is true. As both the conditions are true, we are going to get vertically overlapped. You can run and check. If I run the code, you can see that we got vertically overlapped. We are not getting horizontally overlapped. If I want to check whether both are overlapped, then we are going to check all the conditions. I have to check all these conditions. I just say Control X, hit enter, Control V. If horizontally overlapped as well as vertically overlapped, then I can say that rect1 and rect2 both overlapped. I delete this, Control save. Let me come back to Unity and run and show you. you can see that we are getting nothing. We are not getting anything. That means those two rectangles are not overlapped. Otherwise it will show that you can see rect 1 and rect 2 both are overlapped. We are not getting on the screen that because they are not overlapped. Very simple. And you can see that this makes much more sense, gives you more meaning, and this is easier also than this code. So we have written better code for this. Both are same. This and this are same. Only thing is I have taken these things, I have put them as a properties. So it will be much more easier for us to check the conditions. I can say left easily. I can say rect 1 left is less than rect 2 right, and rect 1 right is greater than rect 2 left, and rect 1 bottom is less than rect 2 top, and rect 1 top is greater than rect 2 bottom. Then I say both rectangles are overlapped. Simple. You can see that this code is more better and simpler than the previous one. So I delete this code above one. I deleted this. I delete these things because I do not want to see those outputs. So this is how you are going to create your own rectangle class if the engine does not provide you to find out the bounding box collision check. This is very simple. I hope you guys have understood, and you can use this method in any other platforms, in any other gaming platforms. If you are not getting there the facility of getting the bounding box, this is a method you are going to follow. Create one rectangle class, get the bounding box, and start checking the collision between those game objects. Simple. Unity also follows a little bit similar kind of method. It considers the left as, let me go back and explain here. Unity considers that the left is x min, bottom is y min, right is x max, top is y max. In these properties also there. With that, there are few other properties like x min, y min, x max, y max. We can use those things also to check the overlapping method. I just want to show you that if I go to MonoBehaviour, you can see that in this one we have a rect structure, not the class. We have here bottom, we have height, we have left, we have let me select all members. You can see it has x min, y min, like that. It has variables which indicates the x and y, width and height. They are the members. M underscore usually they use for telling these are the members. Then we have a overlaps method here. Overlaps takes another rectangle. It does the same operation that we have done. If other max is greater than this x min, other x less than other x min is less than this x max, then other y max is greater than this y min, and other y min is less than this y max. So this is the method which takes which gives us Boolean return type. We can create this one also very easily in our code. What we can do means we can just create one function here, public, which returns a Boolean and says overlaps, and it takes another rectangle, rectangle. I can say here other rectangle, bracket close, opening brace, closing brace. What we can do here, we are going to write these things. I'm going to cut this from here, Control X, and paste it over here, and I am going to say return, return, return. I'm going to put this complete in bracket, and wherever I have rect 1, there I say this dot left, this dot right, then I say this dot bottom, then I say this dot top, and instead of rect 2 I say other rect, other rect, other rect, other rect. Simple. And at the end, semicolon. Let me save this. Now this gives us whether two rectangles overlapped or not. Very simple way we can follow. I can say here rect1 dot overlaps. I'm going to use the overlaps method and I pass to it another rectangle that is going to be rect2 bracket close. Save this one and run and check. We should not get this output. We should not get rect1 and rect2 both overlapped. If I save and come back and run and show you, you should see that we don't get any output. Reason is they are not overlapped. If I give these values, let's take these values, rect1 and rect2, I change, I give 0, 0, 100, 100. So here I say 0, 0, 100, 100 and another rectangle values are 50, 50, 100, 100. So this one is going to be 50, this one is going to be 50. If I save and run, now I am going to get rect1 and rect2 both overlapped on the screen. I come back and run and show you. You can see that rect1 and rect2 both overlapped. So simple guys, are you understanding? We are creating a rect class which is little bit similar to the rect structure in the Unity. It has many different methods to perform. You can see this rectangle asked left, top, width and height. We have given here x, y, width and height. That's it. That's the difference. There are other properties like contains, another point we can check whether a point is within the rectangle, and there are other methods which you can use to perform to solve other problems. That is all about how do we create our own rectangle class and check whether two rectangles overlap or not. How do we write the code, how it is more manageable now to perform the collision check between two rectangles. And also I have shown you there is a rect structure within the Unity which performs same operation that we have done here. It considers left as a x min, right as a x max, bottom as y min, top as y max. I just suggest you to go through that rect structure and try to understand how it is helpful, and try making two rect structures. Try making two rect structures and use the overlaps method and check whether it returns us whether those two rectangles are overlapping or not. That rect2 structure is used by Unity's renderer class, which returns us the bounding box of game objects, and you can use that also to check whether two game objects overlap with each other or on another. We have solved we have solved this design, we have solved the rectangle design, we have solved the circle design. In the upcoming video tutorials, we are going to solve the rect2 and rect3. We are going to understand vector 2 and vector 3 in depth in the upcoming video tutorials, and how the vector 2 and vector 3 help you to place the game objects and how they are helpful in movement of the game objects in depth. A complete vector math tutorials are coming soon, guys. So wait for the tutorials, keep watching, keep learning, keep coding, keep sharing, and also try to create one more method for whether a rectangle contains another point. You just need to write a simple code, just understand the logic and try yourself solving the problem of whether a point is within the bounding box. It is very simple. If you want, you can refer the Unity's rect2 structure also. So thank you guys, thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing. See you in the next tutorial.